Alright, what's up guys? It's Probability by Pitman, Chapter 2, Section 5, Problem number 12. Okay, so poker hands. Assume all 52 choose 5 hands are equally likely. Find the probability of being dealt A straight flush, 5 consecutive cards of the same suit. So to do this, it's probably better to just see how many possibilities there are. So a straight flush just means 5 consecutive cards, so we can have ace, 2, 3, 4, 5. 2, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 4, 5, 6, 7, 8, 5, 6, 7, 8, 9, 6, 7, 8, 9, jack, 7, 8, 9, 10, 6, 7, or there's no 10, I'm sorry, jack, queen, sorry, I was mistaken. 10 is actually a card. Okay, so 10 is an actual possible ring. Okay, so then 10, then we have a jack, 8, 9, 10, 11, or not 11, sorry, jack, and a queen, 9, 10, jack, queen, king, then our last possible one, which is 10, jack, queen, king, ace, since remember an ace can be either the first or the last card. Okay, so if we count this out, we have 10 total possibilities of a straight flush. Remember, or actually before we even talk about that, let's first write it out. So we have 10 over 52, choose 5. But we're not done here, because we have to realize that this is just calculating it for one suit. You know, it could be just the hearts. But they're asking us a straight flush, 5 consecutive cards of the same suit. It doesn't mention which suit it has to be. So while these can all be the same suit, there are 4 different suits that still satisfy this condition. So we'll do times 4 choose 1, where there are 4 different suits. We're choosing 1. We're showing all possible combinations there. So it's equal to 40 over 52 choose 5. And that is our answer for part A. All right, cool. Part B. So 4 of a kind ranks AA, AA, and B. Okay, for this one, we have to choose a rank, and remember rank is any one of these, you know, like ace, 2, 3, each one of those is a rank. So there are 13 possible ranks, and we have to choose one of them. So we have 13, choose one. And then now that we've chosen one of them, now we have to show how many of that rank we want. So of each rank, there are 4 of them, because remember there are 4 suits, and a rank has 1 copy in each suit. And since it's 4 of a kind, we'll do 4 choose 4, since we want all 4 of them. Then we do the same exact thing. Now, since we already chose one of the ranks, we have 12 left. We'll choose one of those. And then this time, while there are 4 of them existing, we only want one of them. So we're doing 4 of a kind. So 4 of one kind, then 1 of any other kind. Then this is all over 52. Choose 5 total possibility combinations. All right, and that's our answer. All right, so C is a very, very similar story. We have 13 ranks. We're going to choose one of them, but we only want 3 of them this time. So there's still one of them floating around, but yeah, we only want 3 of them. Now we do the same thing. Now there's 12 ranks left. We only want to choose one of them, and then we have 4 of them, but we only want to choose 2 of them. So 3 plus 2, 5, we have 5 cards total drawn. And it's all over 52, choose 5. And voila, that's our answer for part C. Now part D, a flush, 5 of the same suit, not a straight flush. Okay, so once again, there are 13 suits, of which, sorry, 5 of the same, sorry, there are 4 suits, of which there are 13 cards each. So let's do the situation for, let's say, heart. So there are 13 heart cards. We want to draw we only want hearts. So it's just 5 of the same suit. Okay, I just wanted to make sure. Okay, so we have 13 heart cards. We want to draw 5 of them. We have 39 remaining cards. We want 0 of them. Then this is all over 52, choose 5. But guess what? We're not done. They're asking for a flush, 5 of the same suit, not just 5 heart cards. So while this situation models, drawing 5 heart cards or 5 spades or 5 clubs or 5 diamonds, we want to add up all of these probabilities. So it'd be 4 times this, or to put it in a more rigorous way, 4 choose 1, since there are 4 ranks and we want to choose one of them. So we're multiplying however many possible combinations there are of that. So 4 choose 1 is equal to 4. So if we simplify this, I'll leave it as 4 choose 1, just for like bookkeeping, I guess. 13 choose 5 over 52 choose 5, because 39 choose 0 is equal to 1. Yeah, and that's our answer for part D. Alright, now for part E. Okay, so a straight, which means 5 consecutive ranks, but it is not a flush, where a flush is 5 cards of the same suit. So this means we want 5 consecutive ranks, but there need to be 2 distinct ranks at the very least. So we can't have 5 of the same. So basically, what we did in part A, we have to exclude all of these realities. Okay. Alright, so to do this, let's remember from part A that, oh, what the hell? What is it? Okay, anyways, we'll remember from part A that there are 10 different ways to arrange the suits, or sorry, the ranks, so that they are consecutive. So we'll go ahead and write that. So 10 over 52, choose 5. And remember how at the beginning we simply multiplied by 4 choose 1, since we only wanted to choose one rank. However, this time, for each of our 5 cards, we need to choose a different rank, or each rank is independently chosen. So we'll do 4 choose 1 times 4 choose 1 times 4 choose 1 times 4 choose 1 on times 4 choose 1. So basically what's happening is we're showing the amount of combinations possible, because for each draw there are 4 different possibilities, and we're choosing one of those possibilities. So you can end up, so under our current situation, you could end up with heart, 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 heart. You could end up with diamond, heart, diamond, heart, diamond. You could end up with club, 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 club. Oh wait, last one's a diamond, right? So all of these scenarios are possible because we're picking each rank, or sorry, each suit independently. And then remember, this is just a generic 10 combinations possible of consecutive cards. Rank doesn't really play a factor here. We're choosing the ranks here. But remember, they're trying to ask us only a straight, right? Which is not a flush. And remember, a flush is 5 of the same suit. So that means while diamond, heart, diamond, heart, diamond is okay, club, 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 diamond is okay, heart, 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 heart is not okay, because we don't want a flush. We do not want all of the same suit, which is still possible in this reality because each one is chosen independently, and it could still be heart, 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 or diamond, 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 so on. You get the idea. So basically, the best way to go about doing this is just to subtract all the realities where you get heart, 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 heart. And luckily for us, we already calculated that in part A, right? We figured out that there are 4 times 10, 40 different ways to get consecutive cards, or sorry, consecutive ranks of the same suit. So since we already did all the hard work in part A, we'll just subtract that number. So now we have this, which is the total number of ways to create um, consecutive ranks, right? So it has all possible ways of having consecutive ranks, which includes having all of the same suit, which we don't want. So we'll just subtract from that number the number of ways to have consecutive ranks and the same suit. So basically we're just getting rid of the realities where they all have the same suit but they're consecutive, but we're leaving the realities where it's a mixed suits but the ranks are still consecutive. Alright, I hope that made sense. But yeah, that's our answer. Alright, cool. I hope that helps somewhat.